Data warehouse applications exist to provide improved management information and reporting on potentially disparate systems. And in order to create the content of data warehouse applications, we use processes typically called extract, transform and load processes. We'll look at how we model and test these ETL processes in this video. So firstly, I'll explain what ETL processes actually are and introduce an example, a simplified process used to extract data from customer systems to provide a management reporting facility. And then we'll look at the demo of ARD modeling and testing the ETL process, and then I'll summarize at the end. Now, ETL processes are in common use with data warehousing applications, and the goal is to take data from potentially disparate sources and merge it, combine it, enrich it, and rationalize it, if you like, in order to provide a reporting facility based on data that is consistent. Now, usually ETL processes are run as batch runs in order to refresh the data in the data warehouse, perhaps overnight, sometimes more often than an hour. ETL processes are often used in migration projects where data in legacy systems might be transferred into a new, revised and better system to replace the legacy. Now, in the process of moving the data, quite often the data itself needs a cleanup, rationalization to fit a new data model. So ETL processes are often used with data migration projects. The transform process is usually where the data is actually improved, enriched, reconciled with other data from other systems, and so on. Now, on the right you see like a generic ETL cycle where the cycle would be the process that runs perhaps overnight, every night, to refresh the content of a data warehouse. So we have like an initiation, we'll build some reference data or download it or copy it into place. Then there's the extract from existing data sources. Sometimes there's a lot of validation required to filter out all the less accurate data that might have been entered in an unvalidated system perhaps. Then the transformation is where the data is merged, deduplicated, cross-referenced with reference data, aggregated or disaggregated, and then loaded into often a staging area ready to be loaded into the final tables. Quite often there's a need to track data that doesn't make it all the way through the process. So the cleaning process might not be 100%. So quite often there are audit reports or suspense files which hold data that can't be migrated through the process. Certainly then the data that might be in a staged area would then be published to the target tables, and then perhaps there's an archive and cleanup and so on. This is the generic ETL kind of cycle that we see again and again. Now, in order to demonstrate how ARD can support the testing of an ETL process, I need to introduce a kind of an example, a case study, which is much simplified, but typical of the kind of processes that are actually in use. So in our example here, the company want to normalize the data in an ordering system to improve management reporting. So it's going to rationalize the data and to generate tables that can be better supporting of the reporting. The three tables that we're extracting data from comprise some order detail, the products against the orders, and the customers who place the orders. These three tables will be linked with unique references in the order table itself. Now, the addresses in the customer details and the addresses in the order details were never validated, so they were just free text, if you like. So the address data, we need to clean that up and match it against a postcode database to get accurate address information. And once it's matched, it's codified, and then we have a more systematic way of capturing addresses in our new system or reporting on a geographic basis. Now the addresses are captured in two places, the customer record and the order record. The target data sets have been defined, and we've created a set of ETL business rules drawn up for the processing and validation and matching and so on. So here are our three source tables: products, orders and customers, and the products are linked to the orders by a product ID, and a customer ID links customers to the orders as well. We also have a postal address file, PAF if you like, and the addresses in the orders and in the customer records will be matched against the postal address file. The output tables, which are generated from the content of the input tables and the reference file, the PAF file if you like, we're going to generate a sales database which contains all the order details and the tidied up customer address IDs, which will be generated from the addresses that are going to be created as we encounter them in the customer and order records. Now those records that have no order ID or product ID information in the sales order record, we're going to write into an order suspense file, and these need some manual cleanup. The link between the sales record and the addresses, we're going to have both the order address ID and a customer address ID, and these two addresses will be referenced. Here's the process in overview. We have the three input files plus the reference data in the PAF, and the three output files: sales, addresses, order suspense files. Now there are some business rules that have been drawn up to manage the transformation process, and you can see if I walk through them quickly. Firstly, all orders have to have a product ID and a customer ID to match and to look up product and customer information in the other two tables. Any orders with missing product or customer IDs will be written to this suspense file, so they'll be analysed separately. The order quantity information will be stored in the sales table when it's generated. Customer addresses and the order addresses will be matched with the postal address file, and if a match is found, the address will be written to the addresses table if it doesn't already exist. And the detail in the PAF file, the full address details, will be referenced in the address table as it's generated. Now if an order doesn't have an address, it'll use the customer address if one exists. Otherwise it'll be matched with the PAF and a record written if necessary. Overall, unmatched addresses will be written to the addresses table with a false value for the validated address field. The validated address field will be true for valid addresses, if you like. Now the overall strategy for testing an ETL process that we adopt with Agile Requirements Designer is we will model the process of validation and table generation and take advantage of the data builder facility to support the testing. What we'll do is we'll create a model of the process and include in that model processes, activities to create the data in both the source tables and in the target tables to be generated. So Data Builder can be used to actually generate all the content of the tables from the perspective of the input and the output. So what we can then do is take the data generated for the input files, run it through the actual process, ETL process itself, and then compare the outcome of the ETL process with the generated output tables from ARD. Now, the way we do the comparison might vary. I mean, if the output is a CSV file, it might be a simple text comparison. But if the data is written to a table, certainly we'll have to build some simple queries to do a row-by-row comparison of the output from the process and the output from the ARD modelling exercise. Now in the demonstration we'll model the ETL process, but we're not going to show how Data Builder is actually used. I'm just going to suggest these are the places where Data Builder comes into its own. But the process of modeling is what I want to show. Now, what you'll see when we get started with the demonstration, you'll suddenly realize actually an ETL process is just another process managing data. So the modeling activity is very straightforward, it's very simple, and similar to the way we've done GUIs, for example, and the decision tables in other videos. When an ETL process is actually designed, we usually find that the business rules need to be checked and tested on paper before the process is built. So I'm going to create the model, but as I create it, I'm actually going to suggest that there are additional rules that need to be applied that weren't in our list a couple of slides ago. But when you do this for real, you would create your model from the rules given from the user community, and then having created your model, you can then feed back what the model is telling them in terms of paths through it. But you can also introduce concepts such as, well, what happens when we create a record and then another record that is duplicated? Do we have to do a lookup first and then create if it doesn't exist already? We have to add these kind of checks into our ETL process to make it work smoothly and not end up with lots of duplicated data. So as you've seen in other videos and the models that I've shown you, creating the model gives stakeholders a visualization of the process. So it can help us to find problems in the actual original requirement. There's no question that when people start on these kind of processes, they don't think through everything because they simply can't anticipate all the actual physical data management activities that the ETL process has to perform. So here we are in Agile Requirements Designer again, and I'll open up the ETL process model that I created earlier. This is the whole model end to end, and I just want to point out the colour scheme just before we get into the detail. Firstly, at the top of the model you'll see an orange process, and at the bottom you'll see another process. These are a header and a footer process. Now these are there to support the Data Builder integration with the tool. So in effect the header sets up the configuration of Data Builder ready to go with later activities in the model. The second colour I want to highlight are the green activities or processes here you can see, and these are where data is written to the either input tables or output tables by the model itself. So this is where Data Builder does its magic and generate the input test data or the expected results. All the rest of the elements, the purple elements, are the decision making and activities within the ETL process that we're modelling. So let's zoom in and start at the beginning and just walk through it. So there we have our start element, the header process, which is just there for the Data Builder integration. And the first check that's happening for every order record is the product ID available. If there's no product ID, we write a record to the suspense file, identifying that order as something that needs attention. We come through if the product ID is okay or whether there's a suspense record. We look at customer ID. Customer ID is the same process. Is there one? If there isn't a customer ID, there can't be a match. So again, write that order to the suspense record and that'll be looked at later on. Next we look at the address match for the customer record, and if there's no PAF match, the variable validated customer address is false. If there is a match, okay, we know there's a record in the PAF that we can look up for this address, so we set the validated customer address to be true. So this is a piece of data that will be used a little bit later on when we start writing address records into the addresses table. Now, if we find the customer address in the database already, we'll use the matched address ID. If this address is new to our database, we'll write that new record into the customer address file. So now we look at the order address. If the address in the order record exists, we then look for it in the address table. If it doesn't exist, we are going to use the customer address that we've already done a match for and checked, and we'll take that path further down the model. So going back to the order address, we look for it in the path. If there's no path match, we set the validated order address as false. If there is a match, we set it to be true. Next, we look for that address in the address database. If there's a match already, so we've already written this address, we don't want a duplicate, so we reuse the matched address ID. If the address is not found in the addresses table, we are going to write a new record there. Regardless, and this is the path from the reuse of the customer address, if you remember. Regardless, we then write a sales record, then we write the order record. You might remember from the top of the model that we checked the product ID and customer ID. So we have these second checks here to keep the model coherent. If we have the product ID, we'll write a product record. If we don't have the product ID, we will drop down to the got customer ID check here. If we've got the customer ID, we write a customer record, otherwise we drop straight down to the footer, and then that's the end of the process. So you can see the process end to end is quite substantial, but it's not a complex model, except it's rather long-winded. Before we complete the model, I need to add some constraints to keep it consistent. So you might recall at the start of the process, we check for a product ID, and if there's no product ID, we write a suspense record for the order. Well, later on, we're going to write a product record if there is a product record to write. So we need to have a constraint to make sure that we don't accidentally write a product record with no product ID. So we have two links which can't occur together. So I'm going to say if there's no product ID, I should not be writing a product record. So that should not exist. Go to the top again. If there is no customer ID, we should not be writing a customer record. Now the second couple of constraints are where we do have a product ID. We want these to drive the generation of a product record. So if we have a product ID, at a condition item, you see down here, we want to write a product record. So you can see if there's a product ID, okay, then got product ID is true, so we write a product record, create that constraint. And let's do the same for the customer ID. So here must occur together. If we have a customer ID, then we must write a customer record. So that's it. That's our 4 constraints which ensure that the model hangs together okay. Now let's look at Path Explorer, and what I'm going to do is just go straight in and look at all possible paths, and we get 48. Now 48 seems like quite a lot, but if you think about it, the ETL process is going to be dealing with many, many records, possibly millions of records. So all possible paths, if the number of paths is within a reasonable bound, we would normally use that as the target optimization for an ETL process. You should realize by now that when we're creating this model with the green activities which actually write the data to either the input records for testing or the output records for our expected results, the whole process is automated. So actually it's quite a good thing to look at all possible paths, and we can guarantee the coverage that we apply is going to be very sound indeed. So one last thing, let's look at the test data that can be generated. I've already taken the default values, and you can see in here the values for all the records that will be either written to the input records or the output records as expected results. Now those records don't have sufficient data in order to be coherent yet, so we'd have to actually add extra fields and values for those fields to generate, for example, randomized customer names. Now that's one of the benefits of Data Builder, which it can do that. So one last thing to show you, if we look at one of the green activities on the model, you can see that there is a Data Builder tab in the properties box, and this is where we can create the configurations for the publishing of data. So this is where the configuration of the publishing of the input data tables or the output data tables, it's where it's done. So when it comes to using ARD to model an ETL process, you have complete control over how the input data is generated and the expected results, the output data, is generated too. So, to summarise, I hope you've seen how Agile Requirements Designer can be used to model an ETL process for the purpose of testing. But just to remind you, by modelling we create a visual representation of the ETL process that we can share with stakeholders. Now what we know from these kind of projects is that the requirements to deal with the data in typically legacy systems tend not to be a complete set. So we usually need to work with the stakeholders a bit more closely with the model itself to walk through the paths that for the scenarios that they've defined. But it's usually the case that there are other rules that have to be added to deal with management of the data and the integrity of the target database. So by creating a covering set of paths, we can walk through the user's initial ideas of scenarios to cover and explore the less obvious paths to create a model that is trusted to do the job. Now, to test the ETL process, we can use the Data Builder feature to generate both the test case data for the input records and the output records, which represent the expected result. So by doing so, we can test the ETL process by using the generated input data and compare the output from the ETL process with our prepared output data created by Data Builder.